So my name is Nilay Yalcin. I'm an assistant professor at Simon Fraser University. I'm a cognitive scientist working on computational empathy and interactive agents. Apologies for not being able to be there in person, but I'm happy to join virtually. I organized my talk into two sections. First part, it will sound like I'm complaining about computational empathy a bit. And in the second, I will show my perspective on some additional opportunities that I see in using AI agents in empathy research. So the idea that people respond socially to machines really predates LLMs. Long before ChatGPT, we had the computers as social actors paradigms. We knew that people assigned gender, personality, competence, social characteristics to machines that were less capable than LLMs. And we had Eliza in the 60s that was seen as an empathic counselor, mainly by using rule-based, old-fashioned AI methods. But it was really easier to break the suspension of disbelief because they could not really keep up with longer interactions and incorporate contextual information. What we have different is today is that these larger models trained on vast amounts of data dramatically increased in coherence, their memory, understanding and incorporating new context and personalization, which made them more believable as social actors. And the stronger the illusion of understanding became, these tools started being widely used as well. We started talking more frequently about AI empathy and its effects. But when we talk about AI empathy and any other complex social behavior, its harms and benefits, and whether or not we should use it for different purposes, I feel like we are hitting some issues as those questions are being underspecified. So the first question for me, for example, what do we mean by AI when we say AI? This might sound like a silly question to have, but we do have a moving target problem at hand. Which AI are we talking about? Is it ChatGPT released on a certain date, accessed by using the API? Or is it any commercial LLMs trained on which data set? Is it open source models, the average model of the day, the best model of the day in terms of whatever criteria you might have, or some future system that does not exist yet? Or it might be even the hype that most AI companies or investors have been pushing. So the question becomes, are we studying human behavior during their interaction with these systems, or are we studying reactions to a specific model to that day? And AI is not a monolithic entity, so the answers that we might be giving are becoming really tightly related to our understanding, the inner understanding of the inner workings of the system that we are basically using. And the challenge becomes even more complicated with empathy. Specifically, in my opinion, empathy might be one of the most complex and fragmented concepts. And depending on the field, or even in the same field, which researcher sometimes you're asking, empathy may refer to many things: emotional contagion, perspective taking, empathic concern, compassion, helping behavior, synchrony, or a combination thereof. And these concepts may overlap at times, but they are certainly not identical. And in our recent review work on computational empathy, we also found substantial variation in how researchers define and use empathy models or datasets. So different papers often evaluate different constructs while using the same label. And this means that before asking whether AI is empathetic, we might need to ask, okay, which part or the component of empathy you are talking about? And so I actually had another complaining slide about how do we evaluate these particular empathy and empathy. And we have in AI, we do have many ways to evaluate human empathy, but mostly with experts or self-report judgments. And we don't necessarily have an agreement in the field on this yet. Jana Borg and Hannah Reid was talking about empathy evaluation yesterday. I was curious about their take as well. And finally, we also need to ask empathy compared to which human. So human empathy a lot of speakers talked about this. It varies enormously between people. It can depend on context, culture, social relationships, motivation, expertise, even fatigue. So the same person may be deeply empathetic in one situation and completely unavailable in the other. So this immediately dissolves many simplistic human versus AI comparisons. Lyle yesterday talked about the cultural variation. This also, again, directly impacts the results of humans preferring empathy, AI empathy over human empathy, and studies related to it, because we've all seen, for example, a rising tendency for youth to turn to the out-of-the-box commercial LLM chatbots such as ChatGPT for counseling, social and emotional support. In our current work with university students seeking counseling support, we actually found that many students preferred AI support not because they believed that AI was better than counselors, but because just AI was available. There is no waiting list, no scheduling, no fear of judgment, immediate support at 2 a.m. over text. So is it really choosing AI over humans, or choosing AI empathy over humans, or they are just basically choosing what is available over the unavailable support? So, okay, I gave you a bunch of problems, and my intention wasn't just complaining. So my point is, I guess, one particular AI model might be behaving similarly of a certain human at a certain time within a particular context. But, what do we learn from it, and where do we go from there? So I mentioned I'm a cognitive scientist, and I see a different way of looking at things which cog-sci folks like to do, which is basically to ask, can we use these systems to help us understand human empathy? So rather than asking whether AI is empathetic, I want to ask, can building or trying to build empathetic agents or agents with empathic capacities help us understand empathy itself a bit better and kind of shift our perspective a bit in that sense? So instead of treating AI as an object of evaluation, we can begin treating AI models as almost a scientific instrument, a tool for studying human cognition, emotion, social interactions, and morality. And I like to think that these systems as computational confederates. So traditionally, behavioral scientists relied on surveys, interactions of scripted interactions. And with these systems, they are adaptive, we can control them, we can parameterize them, and we can reproduce the results. And they are increasingly believable. So maybe we can use these systems instead, or in addition, rather. So I want to talk about a case study and now talk about two complementary pathways to using AI to study human behavior. One is top-down, where you begin with the theories, and the other is bottom-up, where we start from behavioral data. So in the top-down approach, you might already know this. You start with the theory of interest that you have that can be computationally implemented in some way. For example, I worked with Franz de Waal's Russian doll model of empathy for quite a long time. And then the question becomes, okay, if I can implement this theory or parts of this theory, would the expected behavior of this theory suggest that the theory suggests emerge from the model? Or if not, which behaviors it will not predict, or what else I can discover with it? So you try to build agents iteratively with and without those implemented theoretical assumptions, or just one capability at a time iteratively, and you observe and compare the behavior. And if it's an interactive system, you can observe how people respond to it. And this follows very long tradition in cognitive science, building models as not simply as an engineering exercise, but as a way to closely examine theories. And you can improve or expose ambiguities in the theory, discover hidden assumptions, compare competing theories under identical assumptions or under identical conditions. In the bottom-up one, this is very complementary in my view. We begin with collecting behavioral data similar to psychology experiments of the behavior you're interested in. For empathy, you can collect emotional judgments, contextual interpretations, explanations. It can also be multimodal. And then you train models that capture patterns in the data and see the predictions or causal insights on the same or new data so that you can judge whether to compare behavior of the models with and without this training. But also you can combine it with and without the structures the theory suggested from the top-down approach. So in my work, one of the questions I was trying to answer was, what information are people using when they infer emotions and empathy? And we do use AI models and recently LLMs and vision language models, but before that I was using a lot of the dialogue management rule-based models to investigate how people make empathic judgments and where biases emerge. And one of the projects where I also collaborated here at SFU with Angelica Lim, we tried to examine emotional reasoning abilities using contextual images. Originally, we tried the top-down approach, where we were interested in System 1 and System 2 thinking theories. So on top of fast emotion recognition model, you add the slow linguistic descriptors of a given scene. There in the scene, you may have the person, but also like within a context. So we didn't first use any assumptions about the causes and effects of that person. We just used the description of the linguistic description of the scene. So our results show that overall, the models, even with the vision language models, the models that utilize the description of the fast and slow framework achieved the highest score within their perspective, within their trained and non-trained categories, compared to the fast-only or baseline models. So combining both systems was better than just using one or none. Although we gained a lot of performance scores, such as F1, really it tells you a very small part of the story. For this to be useful for us, we need to analyze deeper and look at the specific results. In which cases it's performing better, in which cases it was still failing, what kinds of linguistic information was important. We then later did our own data collection and do a bottom-up approach to incorporate how humans see these scenes and provided their linguistic descriptions and why. So the combined approach of the trained over human data was performed the best. And again, the fast and slow method was overperforming, which with the just VLM approaches overtrained on them. But we also realized that some possible emotions of humans rated really depended highly on the assumptions of the mental state of the humans in the image, the theory of mind, not necessarily coming from the elements from the immediate scene. They were thinking of some long-term causal explanations or perspectives people have require in the future or past imagination. So implicit reasoning in the LLMs were not being sufficient with just providing the contextual information of the scene itself. You needed some long-term causal reasoning and theory of mind. So we started also looking deeper into our results in terms of which condition it fails or succeeds. We did ablation studies, which elements such as action, environment, age, as a way to decode the scene linguistically. And we saw that the most useful elements was the action and environment. And somehow we think it's because of the data set that we are using. This is Empathic, by the way. The physical signals were not providing much, like the facial expressions were not changing the effect that much. And we also dig much deeper into our failure cases, and we realized that our models were again failing to attend attempt or select information or important information in the scene for that specific person. So we were missing an attention module, figuring out the salient elements in the model related to the emotional reasoning. So the models were either focusing on everything or like homogeneously, or just some specific certain elements in the scene. For example, in this one, the image shows two soccer teams in the field, and it looks like the team that is wearing black shirts just won. They seem to be hugging and celebrating, and the team in the white shirt just lost. And we were interested in specifically the emotions of this person. It looked like the model was just focusing on the group that is like more prominent and not answering the question correctly, as it did not focus on the correct elements from the scene. Similarly here, when we were focusing on this boxer, it was trying to incorporate elements from this person's help, when in this case, we don't think it's very important what this guy is doing in this particular moment. So we do not have perspective taking correctly, because we think we cannot guide the attention of the model specifically to the correct elements. And now we are trying to collect new data set using eye tracking equipment for grounding these models and include an emotional attention module. We will really love to collaborate, and we want this to be a large-scale multicultural work. And what is interesting about this is that saliency differs between cultures, people, social situations. It can also allow us to understand these differences and biases, which brings me to another opportunity. And traditionally, we feel like we hit a point where this ground truth phenomena is really hindering us. So traditionally, when we evaluate AI, we use human behavior as a single ground truth. But one of the opportunities we can have with these systems, that maybe they can allow us to compare different perspectives at scale, because they can work on large scale of data. So they may help us surface disagreements, identify blind spots, and reveal how empathic judgments vary across populations. So the goal is not necessarily for AI to tell us what empathy is, and we might use these systems to help us see different perspectives that we might otherwise miss. There are some very recent work on how to model pluralistic alignment and use AI for capturing annotator disagreements that I believe that can move us further from ground truth annotation and comparing towards capturing perspectives, which is the key in empathy. Before concluding, I wanted to briefly end by highlighting more challenges that came up with using these systems as scientific instruments. First, transparency. Much of today's research relies on commercial foundation models that function as black boxes. As these models became more capable, they became really harder to interpret and reproduce. So iterative testing with failure comparisons between models are much more important than accuracy scores. And I believe that combining theory-driven and rule-based approaches, for example, causal variational autoencoders, for example, looks very promising for me to explain model decisions better. Second, unfortunately, power. A very small number of organizations possess data, hardware, and resources required to train these models. This is the reason that we are seeing growing interest in sovereign AI activities in Canada and Europe, as well as stronger collaborations within academia. Finally, I'm not going to go into detail in this because many people talked about it, but psychology has long struggled with the weird problem. Data often collected from Western educated, industrialized, rich and democratic societies. And it looks like LLMs or large foundational models are no different. So if we are to study empathic and social AI systems, we need to really ask whose perspectives are represented, whose are missing, and how do we decide? Thank you. I'm happy to hear looking forward to your questions and comments.
We probably have time for 2 one or two quick questions? Yeah.
Thank you so much. That was a really excellent talk. This is more just a curiosity about things you're pursuing currently. I'm wondering, it looks like you're using static images, and I'm just wondering if you've um, used any kind
Yes.
of dynamic images or like videos, for example.
Not yet. We are exploring the use of videos. However, videos are very difficult to work with, unfortunately. And we were thinking the long-term future and past-oriented perspective thinking we were talking about. We cannot maybe train the models or build theories without using videos. However, yeah, we currently only are using the image data sets.
Okay, one more question. Anyone else? All right, thank you very much.
Thank you.